Right. See, first hop redundancy protocol, first hop route redundancy or first hop router redundancy protocol. This first hop route redundancy protocol is not a protocol. It's just a name given, a title given to set protocols like HSRP, Hot Standby Routing Protocol, and then Virtual Route Redundancy Protocol, Gateway Load Balancing Protocol. For these three, a common name is given that is what we call as FHRP, First Hop Route Redundancy Protocol. First hop route redundancy protocol. A common name. First hop route redundancy protocol. We need to know why we need this protocol. Then we will go through these three different protocols. First of all, what is this first hop redundancy protocol? You know, for every organization, there will be one edge router. Mostly this component, this feature is enabled on the edge router. It doesn't mean that you cannot enable on the inside the organization. You can definitely enable this inside also. Inside in the distribution layer, you can very well enable this. I have seen that. So this can be enabled anywhere, wherever you need a routing, you will have a router. And if the router goes down, you want a backup. You want the backup router to take over. In such environment where you need to have a primary gateway, the router is nothing but a gateway, right? Primary gateway and a backup gateway. We can go with this protocol, first hop redundancy protocol. So that's the scenario, that's the place where first hop redundancy protocol is deployed. Now, already you might have guessed the need of this protocol. This is to provide gateway redundancy. What does the gateway provide? Route. That's why it is route redundancy, router redundancy, or route redundancy, gateway redundancy, all are same. Now let's say you have a LAN switch here to which multiple computers are connected. Right? Let's say we have 40 computers. And this all 40 are connected to this 96 port switch. And this switch is connected to a gateway. I'll call this as gateway 1. Now, let's assume the IP address in this PC is 10.0.0.1/8. Is the font size okay for you? Okay. 10002/8. 10003/8. 10004/8. And now for all this PC, there is a gateway. And the gateway is the G1's address. Let's say G1's address is 10.0010/8. This is going to be the gateway for all the PC. And that is the IP address on this router here. Now, this router connects to the internet. It can connect to the internet. It may connect to the core of the network also. It doesn't matter. As I told you, this can be enabled in distribution layer. It can be enabled in edge, wherever you want. Now, what if this wire goes down? Or what if this router goes down? Or what if this wire goes down? You will not be able to go online, correct? This is internet, I told you. So if the wire goes down or the router goes down, the internet will get stopped. Internet will stop. So what you decided to do is you decided to have a redundancy. You decided to have a redundancy, a load balancing. So you connected a router here. And now you may have a switch here to which you connect. The reason why you do this is for redundancy. If something goes wrong here, the traffic can go like this. Redundancy. But if you want redundancy, what is needed? Tell me what is needed if you want redundancy. You need to have IP of what? For the new gateway, right? Say for example, this one is, if this one is, I'll write on here, 10.0.0.11/8, you want this to be hey, if this is the IP address of this router, you want that to be the gateway which is not possible for you to go and change on every device. It's not possible. See, for me, just to change on this whiteboard itself, see how long it takes. Now, only when you change the gateway, the pieces can now go via G2. Manually changing is not possible. Even if you change, there will be a ARP issue. Why? For this long, in the PC's default route, the MAC address of G1 was registered. But now the MAC address of G2 need to be added by removing this MAC address of G1. Yeah. So this is all going to be a disruptive one, meaning there will be a downtime to do all these changes. There's going to be a lot of downtime, which is not acceptable downtime because it's going to be long time, unpredictable time. It depends on when you found that G1 has gone down. So to find that G1 has gone down itself, it's going to take time. After finding how long you take to log into the control panel network connection and put the IP address, and then new ARP will be initiated. Oh, this is going to take a long time. If there is any VPN session, all will get terminated. All communication will get stopped for a period of time. Not acceptable. So we want this to be automated. How can we automate this? We want this to be automated, but how can we automate this thing? Whenever G1 goes down, we want G2 to be used with very few seconds or milliseconds of downtime. Very few milliseconds. Yeah, see, less than 200 millisecond is acceptable. Less than 200 millisecond delay is acceptable in the voice network. That's the more sensitive traffic, most sensitive. It should be less than 200 millisecond. So, we want some protocol to automate this so that in very small downtime, the traffic should start flowing through G2 when G1 goes down. How can this is achieved through a protocol? Or what is that we expect from that protocol to achieve this? What is that we expect from a protocol to achieve this? We need a protocol to have another address as a floating address and use that as a gateway on the device which is active. For example, instead of using the address of the physical gateway, we need a floating gateway. We need a floating gateway which can float between these two routers with a new identity like this 10 0 0 100 slash 8. And with a MAC address which is also floating, and the MAC address also need to be auto generated. So for example, I'm writing MAC address CCCC, just for example. But every protocol, we have three protocols to do this. Every protocol have got their unique MAC address. Now, this need to be created, and this need to be sitting on top of this when this is alive. If that fails, if that router fails, this floating gateway should go and sit on the next one, the backup one, to make it active forwarder. Active forwarder. I repeat, if you wish G1 to be the primary, you want G1 to be the primary and G2 to be the backup. If that is your requirement, what this protocol will do is it will give this identity to this guy. G1 will have it. And all these PCs, gateway will not be 11, now it's going to be 100. You are right. It's going to be the floating IP. We only assign it. We only will assign it. So this floating IP is assigned as a gateway, and this is a floating gateway. This IP is a floating gateway's IP. Now, whichever the router that is owning this floating router will respond, will forward to the packet, of the packets. It will respond to the packets. For example, if there is an ARP, then if G1 is holding this, G1 will respond. If G1 goes down, immediately this address will be part of G2. Actually, we will be configuring this IP address on both. But whichever is active, if primary is active, then the primary will take ownership of this address. When the primary fails, that address that you configure on G2 will take the ownership of that address. Yeah, this is how the problem is solved. You don't need to go and change the gateway on every computer because you have not given the IP address of the physical router and you have not given the MAC address of the physical router. It's a floating IP address and floating MAC address given by the protocol that you enabled. If you enable Hsrp, there is a Hsrp MAC address. Only the IP address you need to configure for Hsrp, VRRP, and GLBP. Only the IP address you need to configure. The MAC address is auto-generated. Now, the story is The problem of gateway, problem of ARP resolving the MAC address for the gateway is resolved by floating gateway. The floating gateway is what this protocol provides. Yes. Correct. Which is an HSRP MAC address. Correct. No, 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 no. It will be only the HSRP's MAC address. So on this port, sorry, not on this port. On this port, when primary is available, on this port, you will have this MAC address, HSRP's MAC address. When the primary goes down, when this becomes primary, this will push the info saying, hello, I am owning this MAC address. So there is no need for switch to now query. Before switches query, this gateway, the new gateway, the gateway 2 will come and give the MAC address. Right? The kind of reverse ARP. This one. Yeah. This is a kind of reverse ARP. Yeah. So switches now know where is the recent location of that MAC address. The latest location of that MAC address. It knows the recent one, the latest one. The recent one is on another port, not the port that connects to the G1. So on switch also there is no problem. Any question on why do we need this first hop redundancy protocol? Okay. Now we are going to see the difference between these three protocols. The first one, which is called as hot standby routing protocol, and the third one, gateway load balancing protocol, or Cisco proprietary feature. Cisco proprietary feature. And in this gateway load balancing protocol is very, very rare to see. Very, very rare to see. We'll see all three, but I'm just telling you. Virtual route redundancy protocol is very, very popular because it is industry standard. Because it's industry standard. Yeah. So we have the popular one, VRRP, and Cisco proprietary feature Hsrp and GLPP. RFC 3768. Yep. So it's industry standard worldwide. You can see in every vendor device. So I can have gateway 1 as Cisco. I can have gateway 2 as a non-Cisco while we run VRRP. Now, not big differences between these first two. The first two work similar. For example, in Cisco, for the active device, it is called as active, means that is the forwarder, that is the one holding the floating MAC address, that is the one which is taking the ownership of the floating MAC address, and the other one is standby. Standby is nothing but backup. In VRRP, instead of active, it is called as master. And then the standby is called as backup. Master and backup. And the other differences are not big differences, small, silly differences only. Like what? Preemption is enabled by default in VRRP. In Hsrp, if you want, you may enable it. You know, such differences only you will see uh, in these two. And the timer differences. In Hsrp, the timer is 3 seconds to send a hello packet. And to decide that the active device has gone down, it takes 10 seconds for the standby to become active. I repeat, in Hsrp, the hello packets are sent 3 seconds, holding it for 10 seconds. Preemption is disabled. In VRRP, the timer is 1 second. Hello is 1 second. It is not said as hello, it is called as advertised. Advertising time is 1 second. In VRRP, they don't call it as hello. They call it as advertised time. Advertised time, every 1 second it advertises I'm alive, I'm a master, I'm alive. Backup also will say I'm also alive every 1 second. And the hold time is auto calculated. It will be like something like 3 point something, 3 dot something. It is auto calculated. If you change it to 2, it will auto calculate somewhere around 7 something, 6 point something or 7. So what I'm trying to say here is, in Hsrp you can change the both timers, hello time and hold time. In VRRP you can only change the advertised time. The hold time is based on the advertised time, hello time. Very, very correct. And you told it in a very nice way. Based on the advertised time. Auto calculate. Okay. And the timer, if you want to change in Hsrp, you can change even in millisecond. You can make it faster than VRRP. Yeah. You can make it more faster than VRRP. VRRP, I said by default it is 1 second. Hsrp is only 3 seconds. So you cannot say Cisco Hsrp is bad because of the timer. You can also make it equally same speed. Both the protocols are good. Only difference is the proprietary. Many people don't want to have proprietary one. In their company, there will be a rule saying don't use any proprietary protocol. They don't want complication in future when they want to change the vendor. They don't want complication. So they will have OSPF, they will have ISIS, they will have BGP, they even have RIP, but they won't use what? EIGRP. Yeah. Likewise, they will have all VPN, but not any connectivity. Yeah. Okay, so there are many companies like that. They have a very clear rule that no proprietary protocols. Fine. So now what's the thing left is GLB. See, there is also difference in multicast address. HSRP uses 224.0.0, I think 108. Let me check. So it's 102, 224.0.0, 102, whereas multicast address is not same for VRRP and HSRP. It is different. It is it's 118 for VRRP and 102 for HSRP. Whereas for GLVP it is the same because it's same Cisco protocol. 102. Now it was a nice question that you asked. Why do we need this protocol? Sorry, why do we need this multicast? You see, they are going to send a hello packet, right? To send a hello packet, instead of sending to a unicast address, it sends to the multicast address so that it can discover the group members. Right now, listen, you go and configure HSR, you are configuring HSRP in G1. After configuring G1, G1 will start sending hello packet. And when you finish G2 configuring, the hello that is sent from G1 reaches G2. Now G2 has learned I got a neighbor. I have to form a group. We need to work in a group. So to discover the group members who are all going to form a group and provide the service, they need to get discovered. Like a routing protocol discovers, routing protocol uses gateway, right? Sorry, routing protocol uses multicast address, right? Uh, like routing protocol uses multicast address. Like routing protocol uses multicast address to discover neighbor. This first hop redundancy protocol also needs a multicast address so that they can discover the gateways. You can have even up to 4 gateways. Right now I have only 2 gateways. In reality, you may have 10 gateway, but which 4 need to form a group in order to provide this first hop redundancy? They need to know. You understand? So only when they have the same multicast address, they will know that router and me, we are going to form a group, and one of us is going to be active, and the other one is others are going to be standby. You understand why we need this multicast? To discover neighbor, and also it sends hello packet every minute. Which one? VRRP. HSRP sends every 3 minutes. So 3 seconds. VRRP sends every 1 second. Not a minute, a second. So that they want to say I'm still alive. They want to send that to a multicast address so that even if you have 4 members in this group, just by sending one multicast packet, all 4 will know. Sorry. the existence of the other. You understood? Hmm. Of course, they will all be sending hello packets, and they will all be sending to a multicast address. Even if you have G1, G2, G3, and G4, when G4 sends one hello packet, all three will receive. Only one packet you are sending that to a multicast address. That's the advantage of using multicast. If you don't have multicast, then you need to send it individually to 10.0.0.10, one copy to 10.0.0.11, another copy. Hello packet sending unicast is not good, okay? It's not good. Sending to a multicast is good. That's why we have multicast. Any other question? Yeah, that if any device don't say hello for 10 seconds, they are considered as dead. And if that dead device was having a active role, that will be grabbed by other. Yeah. So the hello packets are not sent as a unicast. They are only sent as multicast by every participant of this group. Okay. In HSRP and in GLBP, you need this third IP address to be the floating gateway. But in VRRP, you may use this address as the floating gateway. And when this goes down, this address will be carried to this type. So just as a floating gateway, you can use one of the address from the group member, if it is VRRP. Set. See on router 4, which is actually a router but having an icon of a PC because it is functioning as a PC. I have disabled routing capability on this device and I have given an IP address and a gateway. The gateway that I have given is not the IP address on the router 1 F01 or router 2 F0. So we have a gateway configured. We also have an IP address. Similarly on R5, show IP route. You see, you don't see a routing table. Instead, you see a gateway, and this is the address of our HSRP. We have not configured HSRP, but when I configure, this is what the address I'm going to use. Um, on this PC, virtual PC, I have given a wrong gateway. I should change this to 100. I'm going to change this to 100. It's not 10. Okay. Right now, if I try ping the network in the internet, I will not be able to ping. Why? Because the gateway is not present. See, it's very clearly saying this gateway that you have configured, not. Same story when I try pinging from R5, the ping won't be successful, and also from R4. So now, shall we start HSRP configuration? Very, very simple. One line command only. Go to router 1, LAN interface, the interface that is facing towards the down switch, interface F01. The command to enable HSRP is standby. One is the ID to identify the group members, meaning when I configure on R1, now I am configuring on R1. When I configure on R2, On R2 also, correct. So they will form a group. Yeah. So that they will form a group. That's the idea. That is how they ID. That is how they identify the members. Yeah, that's how they identify the members. So I have a group ID and IP. What IP I want to have? 172.16.0.100. That is all to enable HSRP. Basic, simple HSRP is only this much. Now you need to put the same command on R2. Right now, R2 is not configured. I'm going to R2. Interface F01. I put the command. Done. Now I'm waiting for the logs to come. You will find a log. Okay, I can see here R1 is moving from standby to active. Now, this number that you have specified here, no? That is what the group ID is. See, GRP means what? Group ID. You can also see this number in the MAC address of HSRP. You see this command, show standby. This is the group ID and this is that ID in the MAC address. See, 07AC is HSRP's ID. If you find a MAC address with 07AC anywhere, you should be sure that we are running HSRP. Now, the last number 01 is the last number 01 is, what is that? Group ID, I just told you. If you see zero C is Cisco. That's the vendor ID. And in Cisco, 07AC is HSRP ID. And this last is the number that you specified as a group. Okay, now you see the hello time is every 3 seconds. The whole time is 10 seconds. And the standby router is the router with this IP address. Who is this? Router 2. Okay. Now, what is the local priority? 100. What is the priority on the standby device? 100. Is the preemption enabled? No. Okay. Now, what is next? We are going to test it. Go to the virtual PC first. Last time when I was pinging, it was not pinging because this gateway was not present. But if I now ping, the ping is going to happen. Yeah, it's pinging. It is pinging because the gateway is present now. I didn't ping the gateway. I'm pinging the final destination, which is the internet. I'm able to ping it. Yeah, I'm able to ping. We are also going to ping from the other two test device. I'm able to ping from here also. What about from R4? I'm able to ping. Do you see the reachability? Great. Now I want to know via which path it is going. We know one thing, when I see active, that is the router which is going. I know that. We all know that. It is not going where router 2. Please show standby. On router 2, the command is what? Show standby. It says this is only a standby and this is only a backup. The active router is the one with this IP address. But we want to test it from the client. So I'm going to router 4 to trace the route. Instead of pinging, I'm going to say this time trace. Now you can see it is going via 172.16.0.10. Who is this 172.16.0.10? Exactly. Wait, sir. Wait, sir. Wait. Now we will do one thing. We will make our let's say our policy is whenever R2 is available, we want R2 only to be a primary. We, our our most preferred active device is R2. So what we can do is I'll go to R2 and set the high priority. You understood why now we need priority? Interface F0/1, I say standby 1 priority. I'm going to say 110. What is the default? I have said 110, but still this will not become active. Why? When they send the hello packet, they compare the priority. R1 knows that, you see, I'm in R1 now. R1 knows that R2 has got more priority. Do you see that here? Standby router has got more priority. It knows. R1 knows I have low priority, but R1 still not giving up the active position. The reason is R2 is not grabbing the position. If R2 need to say, hey, I got the high priority, I am the one who's supposed to be active. To say that, you need to enable, very good. To say that you need to enable preemption, that is what called as preemption. When a superior hello is found, that the one who sent the superior hello should become active. For that, this feature preemption is needed. Let us go enable preemption. Interface F01, standby 1, preempt. As soon as I do this, you see it will grab it. You will see now, look at this. It has gone from standby to active. So let us check now. Let us check show standby. Show standby. Now this has become active because you enable preemption. This is priority 110. Whereas the standby device is the one with the 100. Now go to router 1 and check the same. It says I am only a standby now. Here you can enable preemption if you want. If you want. Here it's not so important because the other one is the one which is having high priority. Okay. Now let us trace the route from R4. Last time it was going via router 1. This time it goes via router 2. Clear? This is Hsrp. So according to what we have learned, if this router goes down, this will become a standby. Sorry, this will become active. Am I right? R2 is the active device now. The reason why that is active is it has got high priority and preemption is enabled. If this link goes down, even then R1 will become active. My question is, if this link goes down, will R1 become active? No, it won't. Why? Because we did not enable Hsrp on that interface. But if this link goes down, then also you cannot go online. Correct? No? Hmm. So if this link goes down, then also you want to make this as active. How can you make it? Very easy. You can tell the Hsrp which is here, you can tell this Hsrp to track this interface. You can tell this interface to track this interface. Which interface? The WAN interface. The internet facing interface. Track. You understand the word track? If that fails, if that port fails, you can ask Hsrp to decrement the priority. If I decrement 20 priority, what will become the priority? 90. Correct? What is the current priority? Yeah. So if that link goes down, I'm going to ask Hsrp to decrement 20 so that R1, which is enabled with the preemption and the default priority 100, will become, yeah. See, that is why I enabled preemption here. You understood? Shall we check? Okay. Now, I'm going to R2, interface F01, and I'm saying standby 1, track. You understand? Track. Fast Ethernet 0/0. Yeah, 1 minute, please. But what I have not said is, I have not said to decrement. How many number I said? 20. 20 or 40? Let's decrement 40. If I decrement 40, what it will become? 110 minus 40 is 80, no? Hmm. So let's see what we have configured. Show run interface F01. I've said track I've said track F01 40. Okay. Now what does it shows? It shows this, but I have configured. Okay. Let us see this. Show standby. You see, it clearly says I have asked to track this one. Do you follow? See, on the running configuration, it is not showing that. It has created a track object one, okay, automatically. And it is tracking this interface. Right now it is up, so it is not decrementing. Only when it goes down, 40 will be detected, and this will become 80 if that link goes down. Okay. Now I want to show you this. I'm on R5 now. I'm going to say ping, repeat 1000 times. As this ping is going, I'm going to shut down on R2 interface F00. Okay. Now, when I shut down, R1 should become active. You see, R1 has become active. You see that? Hmm. Now let's go back and see whether the ping is still going on. Yeah, you did not lose much packet. Okay, only 3 packets you lost here. You see that? 3 dots. Only 3 dots. You see? 997 packets were successful. Okay. Now let's go to R2 and see what has happened. Show standby. You can see the priority now 70. And this has become standby. Earlier it was active. Now it is standby because the F00 gone down. The decrementation has happened. 40 got deducted. Yeah. Now let's do one thing. Let's go back and start the ping again. And on R2, I'm going to unshut. Now see, it has to come back here. See, it has become active. Do you see that? It has become active immediately. Okay. Now let's go back and see. The ping is happening. There is no drop at all. 100% success. And trace the route. It's still it is going where the router to. It's going where router to. Trace route. 3.3.3. It goes where router to. Not even a drop. And router 2 is the active now. Show standby. This is the active one. See, 110, not 70. This is Hsrp. Easy, no? Next is BRRP. Okay. Now let us see the hello packets that are sent. Debug IP packets. You can see the multicast. This is the multicast address. FF 224002 is the version 1 Hsrp multicast address. Now let us change version 2. Or you can also see by using Wireshark. In Wireshark, you can see Hsrp using 224002. You see here, Hsrp 224002. Now I'm going to do what? I'm going to change this version to interface F0/1 standby version 2. Simple. Go to R1 also and say interface F01 standby version 2. Now if I put this command again, debug command, debug IP packets, you can see now, you see one or two? You see here, 1 or 2? All right. Yeah, version 2. You see? Hsrp v2. Okay. So next is BRRP.